Okay, I have my 3-minute timer running, so I have 3 minutes to talk about this. What I'd like to do is put a couple of meters on this so I can see what's going on. And those are output devices. So I'm going to put a voltmeter here, okay, and I'm going to put an amp meter or ammeter to measure current, and I'll put that over, I guess, right here. Okay. Now I have to break the circuit so I can put it in there. I think I can just click and drag. Yeah, let's do that. It's quicker that way. This one, I think I can just drag that up. See how it broke my circuit? So it's pretty good. I mean, it's free. It's good for the price, and can't complain. It's really pretty sophisticated. So I'm gonna connect these dots back. I'm gonna add a wire, W for wire. I'm gonna add a wire to my battery so I can measure the battery voltage here. And that's good right there. So quick visual, no red dots. It should work. Let's turn it on. And I'm going to slow down the simulator because it's jumping a lot. So it's not so, jittery. So I have 5 volts. Let me double click on the battery source. I'm going to change that to 12 volts, 12 volt car battery. 12 volts, I have 1.2 amps through that lamp. Let's double click on the lamp. And I could probably adjust it a little bit. That's 100 watts. That's quite a bit. Let's say it's a 12 watt lamp and it's a 12 volts. Okay. So now I've got 10 amps through there. That's surprising for 12 watts. I should have 1 amp through there. And just wondering what could be going on here. Let's make this 100 watts. See how this affects it. Wow, that really changed it. So let's change the nominal power to 1 watt. I'm trying to get, well, I'm getting ahead of myself. Lamps do not act like resistors. When they heat up, their resistance changes quite a bit. Numerically, though, I should be getting, you know, 1 amp right there. 12 volts times 1 is 12. So if I have 12 watts here, I should see 1 amp right here. So I'm not really sure what's going on. This is it's a simulator, so sometimes you have things that don't seem quite right. Let me stop that. I've got a few seconds left. I'm going to delete that lamp and I'm going to throw a resistor in its place. Okay, so resistors behave very well. I'm going to put what am I going to put there? A 12 ohm resistor. Okay, so 12 volts, 12 ohms, I should get 1 amp, and I sure do. So I like the simulator, but sometimes some components don't act the way you think they should. And I've always stayed away from incandescent lamps because it's difficult to predict their exact behavior. And I think that's the problem that the software is having. So this is like a lot of the examples we're going to see. You connect it, you turn it on, and you don't get the results you might expect. So I'm going to stay away from those types of circuits because it'll be confusing since you may not be aware of how these components act in the real world. Resistors are extremely predictable. If I change this to 6 ohms, I should get 2 amps of current, and you see that you do. So there is a relationship between voltage, current, and resistance. It's Ohm's law, and it's just the basic equation that we use to calculate basically the current based on the voltage and the resistance. Okay, so I'll stop this video here because it's running long, and I'll make another one with different types of circuits and try to show you how that looks.